Operator Series Part 3. If you haven't had a chance, go back to Part 1 and 2 and review around pump intake and pump discharge pressure, along with GPM flow through a nozzle. This particular part will go over friction loss. And there is a formula that we'd like to go over for friction loss. And this would be something that you may find on your pump chart. In looking for friction loss, there are three components that we'd like to break down. The formula for determining what friction loss is going to be the coefficient of the hose, that is the size of the hose, and this is a figure that is found usually in a table that the manufacturer will put out about their particular size hose. Then we'll talk about Q, which stands for quantity of water, and we'll talk then also about length, and that is the length of your hose line, and we'll talk a little bit about how to break that down. So in determining friction loss, we need that coefficient from the table, and we're going to find these on your pump chart. The next is going to be the quantity of water, and since we're trying to break this down and make it a little easier to figure out what friction loss is, the quantity of water divided by 100 gallons per minute gives us Q. So if we take the quantity of water, which let's say 200 gallons, divided by 100 gives us 2, and then we square that particular number. It's important that we take the quantity and divide that by 100 first before we square that entire equation, and that is for the purposes of the higher order of math. Next, the length is determined in however many 100-foot sections of hose that you may have. So if you had two 50-foot sections that were together, it equals 100. They're talking about 100 length. So if you had a 100-foot hose, that would be your 100-foot length divided by 100. So you would only have one section of 100 feet. Again, friction loss is the coefficient of the hose size, your quantity of water divided by 100, and that's squared, times however many 100-foot lengths of hose that you have. Okay, so if we have this formula here that's given to us, and you're going to find that also on your pump chart, let's work through some examples. All right, on our first example here, we have for friction loss, we have an example of coming from our pump discharge all the way out to the nozzle here. And our nozzle, where we get 150 GPM, if we have an automatic or a fog nozzle and that has a particular GPM setting on it, that's where we, if we supplied that with the appropriate pressure, would have that much GPM coming out of the hose line. So that number could be given to us depending on what our nozzle person tells us. We have here set up 200 foot of 1.75, that's 1 3/4 hose. And as we work down this equation, we start off with plugging in the numbers into our formula. So it's not very hard, we just need to know what the formula is. So do we have all the components that we need? Do we have the coefficient off of our pump chart? Do we have the quantity of water, the 150 GPM to plug in there? And do we have the length of hose to plug in here for the length? And we do. So friction loss equals, as we plug this in, 15.5 times 150 divided by 100. You're going to do that math first, and that is squared, times 200 divided by 100. And we simplify that down to the next line. And you'll find out when you do your calculations for testing or for promotional purposes, it's important that you write everything out. You're able to tell where your errors are at or where you may not have done your multiplication correctly and something just doesn't seem right. So if we come down to this next line, the friction loss equals, I'm dropping down 15.5 times 1.5 squared times 2. Now if you already know the answer to this, you can simplify that and plug that in right there if you wanted to. but this is just making it even more simple as we bring that down even further to simplify. 15.5 times 2.25 times 2. And if you had a calculator, you can run all of that, and it would come up to 70 pounds of pressure per square inch. So 70 psi would be your answer. And the 70 would be the friction loss it would take for this line. And we put a plus 70 right there. Now, keep in mind that is just enough pressure to operate and control everything between here and here. Not enough if appliances were in line, or enough to drive the nozzle over here itself. Okay? And we remember what our generic settings were for our nozzle. So just for friction loss in that line of 200 feet of 1 3/4, we have 70 psi is what it's going to take if we want to push out 150 GPM through that line. Our next example. Here we have a smoothbore tip on the end of a hose line that was similar, 200 feet of 1 3/4, but in this case, rather than having an automatic nozzle or a variable nozzle with 150 GPM as our setting, we have a 1-inch tip. And if we remember in our earlier videos when we did the 29.7 times the diameter squared times the root of nozzle pressure, we came up for an inch tip was about 209 gallons per minute. So we plug in that 209 here as our quantity of water divided by 100. So as we fill in our formula, friction loss equals the coefficient of the hose times the quantity squared times the lengths of hose in every 100 foot of sections that we have, and we simply plug in those numbers. So the coefficient for 1 3/4 hose, 1.75, is 15.5 times that GPM 209 divided by 100 squared times 200 foot of hose divided by 100 to give us the sections of 100 foot hose. And we simplify that even further. 15.5 times 2.09 squared times 2, and simplified even further. We simply run the calculation on our calculator, and it comes out to be 135 psi to drive the line all the way up into the nozzle. So the friction loss to move water through this hose is going to be approximately 135 psi. All right, in our next example, we have friction loss to be determined from one engine, let's say going to another engine, and they require 500 GPM in order to operate the nozzles and flow appropriately for whatever they're trying to supply. So we have here 400 feet of 4-inch. We simply use our formula, friction loss, which equals coefficient of the hose we're using, times the quantity divided by 100 squared, times the lengths of hose for every 100 feet of hose used. Let's plug that in. Friction loss equals, if we look up the coefficient for 4-inch hose on our table, if it's not on our specific table, we would have to look at the manufacturer or some of the generic tables that are out there or in your textbook. So for 4-inch, the coefficient is going to be 0.2 times the quantity, which is 500 GPM is what we need. That 500 divided by 100 gallons per minute gives us 5 squared. Next is times, I have 400 feet. Okay, so how many sections of 100 feet is that? 400 divided by 100. That brings us down for even more simplified. 0.2 times 5 squared times 4. Simplify, 0.2 times 25 times 4. And that comes out to be, after we run the calculation, to 20 psi. So in order to push 500 gallons a minute through this hose line here, I would need approximately 20 psi to do that. And that's our final example that we have for this presentation. Thank you for attending part 3 of our pump operator series. I hope that going over the basics of pump discharge pressure, figuring out what gallons per minute are going to be through a nozzle, and also how to calculate friction loss by using a simple formula, CQ²L, in order to determine that, and how easy it is to plug those numbers in order to get the appropriate amount of pressure through that particular section of line. Coming up in part 4, we will be going over elevation loss, and we'll also be going over appliance loss. So I look forward to seeing you soon. Thank you very much for watching.